Bonjour everyone, my name is Hussein Khansa, and today I am representing a part of my PhD called Prominent Discord in Climate Data through Matrix Profile Technique, detecting emerging long-term pattern changes and anomalous events. This work is done under the supervision of Professor Carmen, Gervet, and Dr. Audrey Brouillet. An overview. At first, we start with introduction just to see the scope of our work, the main challenge we're facing, our approach to tackle these challenges, the data that we do experiment on, and the result of this experiment and comparison with other algorithms. And we finish with conclusion and future work. First, climate affects many sectors in our world, including global water, agriculture, energy supply and demand. Due to many sectors, climate data are huge in size and number and have many variables to assess the impact of this climate. One of the main application of the analysis of climate impact is analysis of outlier. This outlier can represent extremes impacts or change. An example of this extreme impacts are drought, flooding, storm, and wildfires. One challenge is defining an extreme in a climate is there is no specific way. It depends first on the variable. It depends on the location. Even in the same country, you can get what an extreme is different. The way we want to define an outlier here is the way that machine learning basically define it. It's called outliers and observations that is significantly dissimilar to other data observation or observations that does not behave like the expected typical behavior of other observation. This will allow us to generalize the anomaly. What is anomalous or not by this definition? It don't depend on expertise or which area we're studying. The algorithm itself will learn the typical behavior. To learn this typical behavior, there are two main methods. The first one is called supervised learning, and unsupervised learning is the other one. The main difference between them that is supervised learning depends on existence of labeled data, while unsupervised learning does not. There are two types of outlier, point-wise outlier, and this represents the object that is detected as an outlier will represent a point in the time series, while pattern-wise outlier represent a group of consecutive points that represent the outlier without, even if a point itself is not an outlier as a group, together they present an outlier. Here we call this pattern-wise, we call it discord. So our goal is to detect inside and field discord in climate data. We'll use unsupervised approach, learning approach, because the existence of labeled data in climate is very difficult, and especially in outlier, that what is an outlier or not, as we say, because the definition of it is depending on the expert. And we want to use, as we said, the goal is discord, not point one. We need to detect the pattern-wise anomalies. To detect the discord, we choose to use matrix profile. It's a state-of-art algorithm. We choose it because of the three main characteristics. It's exact, so it will give the optimal solution every time it runs. It's parameter-free. It don't need a parameter to tune the performance of the algorithm. It does not require the user to set similarity or distance threshold, so the result will not change depending on similarity or distance threshold. That normally what they use to detect anomalies. Basically, matrix profile, what we do is for each subsequence, we define the window lengths, and for each subsequence, we compare the distance between it and all its neighbors. If we look at here at the picture, at first it starts the red one, and it compare it to the distance with blue one, and then it slide and compare the other sequence. They compare the distance. They use z-normalized Euclidean distance. By using this measurement, they will create what we call the distance profile. And then after they finish the blue line reach the end, the red line will move, and again we'll do all the calculation. So we'll have a matrix. Here we can see the matrix. The matrix profile represent the shortest distance, the minimum distance in each distance profile. And the one at the end, what we call motive, and present the most repeated pattern, while the top, and this is our interest, represents the discord. So the discord is the sequence which have the highest distance with its neighbor. So the main challenge, as we say, is we want to detect is it take an input window. So how we choose the window, because if we choose, like, let's say we're working in daily data and we choose 30, so basically this anomalies will represent the anomalous months. The discord represent anomalous months. If we increase it to 90, so this represents 3 months. So the solution is to run it, recommend solutions to run it over multiple variable lengths profile. It can be months, years, and stuff. But this raise another challenge is that leads to generation of large number of discords. So how we can extract and cipher discords, and now there's no way, there's a method like to calculate matrix profile in different size, but there's no way to rank them and choose which one. So to address these challenges, we introduce the concept of prominent discord. A prominent discord is a discord that subsume multiple variable lengths discord. They are the discord that share the same starting time at the window size change. As you can see, look at the picture. We run the matrix profile. We run the matrix profile on window size 13, and this represents the top discord. And then we run it, and we can see it as 37. It has the same starting date. And we look at 5.8, it also has the same starting date. So at each time we run the discords between this, between 13 and 58, they all sharing the same starting discord. So our approach to detect this, to detect the prominent discord is run a matrix profile on different lengths. Select the top discord from the matrix, from each matrix profile, store them in a vector. This vector, we'll call it discord profile. Group the discords that share consecutive starting date, and we rank them based on the number of subsumed discord. The one with the higher subsumed discord will be ranked higher. As we can see in the picture, we see a discord profile. The x-axis represents the window size, and the y-axis represents the starting date. What we want to look, basically, can look on the straight line, and the straight line that have the longest one will be ranked higher. I see, like here and here. So this will be the top. So basically, we run, as we say, we run on first our method to use it. We run discord profile to compare the variable lengths. As we say here, we lengths of the time series over 2. It can be reduced depending on the user. If you don't want like everything, you may like big discords are not interest of him. But for us, we calculate everything. And for each window size, we calculate the matrix profile. The algorithm used is STOMP. This is the way that I explain matrix profile called brute force. This STOMP is faster. It reduces the time it calculates the distance between sequences. It uses fast Fourier transform to do that. So the calculation will be faster. And from each matrix generated by STOMP, we'll extract the max distance and we put it in the distance profile. Then in discord profile, sorry. And then in discord, we traverse the discord profile and we look for discord that share the same starting date. And they should be consecutive. So if there is a discord that like let's say at length 20, it have different discord than before, and after 20 have the same discord, we'll flag them as separate prominent discord. They are not the same because in the middle they are not consecutive. Our data that we run our test is runoff data. They are represent the flow of water running off land surface during and shortly after rainfall. This data extract from GRAN. This work is done like to reconstruct the global runoff. It uses stations all over the world. It covers the duration from 1902 till 2005. It represents a gridded data. The grid size is 0.05, each one like it's the box. We focus our analysis on the Sahel region in West Africa, particularly a soil water vulnerable area. So what we did is like this a box. We can see this box. We average all the monthly runoff data and generate a single time series. This result represents the top two discord, the top two prominent discord we detect. The first one, it's from 1910 till 1988, which has, after we analyze it, we found that it has the higher soil water amount and larger interannual variability, because the time series, like as time go on, the trend is down. So it's the quantity of water becoming less and less in each time, and this period represents the one with the highest amount of water, of runoff. The B is from the period of 1982-9 till 1992-9. It represents the most severe drought period. Like this one has the drought period compared to all the time series. We compare our approach with other algorithms. The first is hot sacks and rare rule anomaly. They are similar, that both they discretize the time series using sacks, but the way that they detect the discord are different. Hot sacks use build suffixes tree, while rule anomaly use generated grammar rules. They detect different. Both of them are approximate because they discretize the data. SCIMP is also an approximation algorithm that calculates variable length matrix profile. So this algorithm calculates the all length matrix profile, but also approximating it, but in a faster way. So to compare in our result, first, this result from Discord is our result. If we can look at hot sacks and RRA, they give different, like here, they are different because they are not exact, so we'll not get the same discord, while our prominent discord will always get the exact because it was matrix profile. Both of hot sacks and RA, you need to specify the window size, so they don't run on variable lengths. So, and the other one is SCIMP. As we say, it's fast in calculating the variable length matrix profile, but it has no ranking for it. As you see, like when we extract the top 5 discord, they just pick the largest one. This is the max window size, and they go down. Conclusion: in this paper, we proposed a new concept in the realm of variable length discord, the prominent discord. It focused on identifying anomalous pattern that lasts through time and subsume sets of discord. The main contribution are the formulation of the methods to compute the prominent discord. So this is our main contribution. Our ordering and results show the relevance in the field of climate data series. In particular, they show that through such ordering, we gain insights on the anomalous pattern that have lasting impact. This is the drought period and the retain change behavior in time series. In our future work, we want the integration of point-wise anomaly detection algorithm with the discord detected by the variable length matrix profile to create an order based on how each discord is anomalous by counting the point of anomaly point detected. We're using, for now, we're using MAD and Prophet algorithm to detect this anomaly ratio. Thank you very much for listening.